All right, hey Olivia, this is the second half of the notes that we started on Wednesday. It was 1-6. Ugh, look at all those notes. That looks really terrible. Solving systems of equations. And in 1-6, we did like solving by graphing, and we're trying to solve and find where they cross each other, okay? And graphing is kind of a pain in the butt. I don't usually like to graph a whole lot, just because even after I graph, sometimes it's hard to see where that point crosses exactly, especially if your graphing is terrible like mine. So like I'm guessing it's at -4.5, but I don't really know for sure. Like I don't know what the exact answer is. So it might not be exactly that point. So that's kind of the downfall of graphing. One, it's a pain in the butt, and two, you still might not get an answer that's very nice because you have to kind of guess where that point is at, where they cross. Okay, you're still going to end up with no solutions, one solution, and infinitely many solutions like this thing going on. But I'll kind of show you what that looks like. So we are doing, on the backside, something called substitution and something called elimination. And kind of like the benefit to this is there's no graphing and you will get an exact answer. The downfall, if you screw up in the beginning, your whole answer is going to be screwed up. So that's the pitfall to this, okay? All right, so let's do this one. This first one is substitution, okay? When you are doing the substitution method, you have to solve for one of the variables, okay? You have to solve the equation for one of the variables. So what that means is that, like here in this example, I'm going to use the substitution method for this one, and it says use a calculator. We're going to do this without a calculator because we don't need one. It says Alejandro has a computer support business. He estimates that the cost to run the business is represented by this equation, and he also estimates that the income is represented by this, okay? So kind of we talked about before how like cost can go like this, and then your income can kind of maybe go like this, right? And we're trying to figure out at this point you end up with a profit, right? So we're trying to figure out how many things we have to produce or how many lawns we have to mow before we start hitting a profit, okay? So what we have is these two things going on at the same time. Y equals 48x plus 500, and y equals 65x minus 145, okay? Now the really nice thing is that we have, it says we want to solve for one of the variables, okay? I technically have 4 variables going on here. I have a y and an x and a y and an x, okay? And only one of those 4 things has to be solved for, but technically in this one, I have 2 y's that are solved for, which is super perfect. Like I don't have to do any work solving for y or getting y by itself, right? Okay, let me show you what this kind of looks like when we have something down here, right? So let's say we had one of these. I could solve for x or y or x or y, and you want to pick the nicest one, right? So like if this is the case, like solving for x and y, like they're all going to be ugly because I'm either going to have to divide by 5 or divide by 3 or divide by 8 or divide by 3. So it's all going to be kind of ugly, right? Okay, versus let's go down here and let's talk about, yeah, they're all going to be kind of ugly. That's kind of yucky. Let me go to your homework assignment and see if there's one that's nice to solve for. Let's go to like number 6 right here. So you have to do number 6. This is on skills practice. I'm just going to like look at this one, right? So we have 4 options. We have this x, this y, this x, this y. Which one would be the really nicest one to solve for? There's actually 2 of them that would be really nice to solve for. Which 2? The top x or the bottom y, because they don't have a number attached to them. All I have to do is put the other piece to the other side, right? So when you're doing substitution, you want to make sure that that happens, right? And then what you do is after you solve, like this x, if I add the 3y to the other side, okay, I have x is equal to 3y plus or minus 12. Okay, then what do I do with that? Do you know? 3y minus 12 can get plugged in for x down there, right? That's what we're going to be doing when we substitute, okay? So let me go back up to the example up above there and show you how this works. So we have y solved for on both of them, which is really nice. So I'm going to take this y and I'm going to plug it in for the bottom y. So all that stuff is going to go in this place, right? Does that make sense? I'm just going to take this whole chunk and it's going to get swapped out for y, right? So 48x plus 500 is equal to 65x minus 145, okay? And then we want to solve. Okay, I've got 4 pieces. 1, 2, 3, 4. What would you like to move first?
The 145.
You want to move the one? See, I don't know why you guys do that. You guys in that 8th period class do that. I always worry about the x's first because I never want my x's to be negative.
Yeah, but I also want the numbers to be away from each other.
You like to have the numbers together?
The regular numbers without.
Okay, whatever. I'm gonna put which one do you want to move out of the 48 and the 65?
48 to the 65.
Move the 48 to the 65. So I got 48x minus 48x. Okay, so I've got, I just always move the x's first because then I make sure he's not negative.
It just feels weird.
Okay. 65 minus 48 is 17. 17x and then minus 145. Okay, now we got the x's together. Now let's move the, we'll finally do what Matthew wants. And we'll add the 145. So 645 equals 17x. And then divide by 17. So x is going to be, please let it come out to be nice. I don't know.
I remember doing this.
645 divided by 17?
37.9.
Ugh, 37 point what? 9. 37.9. Gross. 37.9. Okay. Now, how many customers will Alejandro have to, will he need in order to break even? 37.9 or probably about 38 customers. 38 customers. Okay. 38 customers. Okay. Now, all right. I'm going to ignore this second half of this question for just a second. What will the profit be if he has 60 customers? If he has those 38 customers or 37.9 customers, what will his profit be? If I plug into one of these two equations for x, I'll solve for y, right? Y is equal to, let's just do the top one, 48 times 37.9 plus 500. Okay.
231 or 2,319 and 20 cents.
There we go. So that's what his profit will be if we plug the 39.7 in. Get used to plugging the first variable back into the equation because we'll have to have both of those things for your answer. Okay. Now they say what will his profit be if he has 60 customers? We would then just plug 60 back in instead. Okay. I'm not going to do that part. So we'll just leave it like that, 37.9, and then $2,319.20 is what he will be. Okay, that's substitution. You're plugging one thing, like one chunk in, and substituting it for the variable, right? Okay, all right, example 5. Now they're saying use elimination. Okay, so elimination means that I want to be able to look at this thing and I want to add these two equations together. And I want to either cancel the x's out or cancel the y's out.
Cancel the y's.
Okay, cancel the y's out. All right. Now, 3y plus 3y, if I add those together the way they are right now, it would be 6y. So they don't cancel right now, but what do?
This is the one where you times the top row by -1.
Yep. Or you could times the bottom row by a -1. It doesn't matter, right? And it wouldn't have to be just a -1, like if it needed to be multiplied by 2 or multiplied by 4 or something like that. You can multiply any of the equations. So you want to do the top one by -1?
Yeah.
Top row by -1? Okay. All right, so this would be -5x minus 3y equals
19.
positive 19. Yep. And then I'm going to rewrite just the other one right below it. So 8x plus 3y equals -25. Okay. Then I just add them together, right? And just like we wanted it to happen, -3y plus 3y should end up going away. And if it doesn't, then I did something wrong, right? What's -5x plus 8x?
-3x?
Should be positive 3x because the 8 is positive, right? 3x equals what's 19 minus 25? -6. Okay, then I'm really close. I divide the 3. So x equals, that'll be like a -2?
Yeah.
Okay, and then I can plug in, right? I have to plug back in to solve for y, right? Okay, and you get to choose where you plug into. It does not matter, right? It's kind of like which coordinate do you pick to plug in for x and y. If you have 2 of them, you can pick whatever you want. So let's just do, which one? The bottom one? Sure, the bottom one. Okay, so make sure you're plugging in for x. So 8 times -2 plus 3y equals -25. Okay, so Aubrey says -16. Okay, plus 3y equals -25. And then what?
You have to add the 16.
Plus the 16 over, plus 16 over. Okay, now there's no x attached to the 16. Did you say x?
Yeah, 16x.
It shouldn't have an x because you're plugging the negative 2 in for the x. So the x is gone.
Oh.
Yeah. So I have 3y equals negative 25 plus 16 is like negative 9.
I think, yeah.
And then divide by 3. Y is negative 3. Okay, now I also like to write my answer, my final answer as an ordered pair, like one of these, right? What would that ordered pair look like?
-2.
Yeah, x is negative 2, y is negative 3. Okay, now negative 2, negative 3. Why do we care about that thing so much? Like, that's the answer, but what does that do for me?
It
Like,
solves it.
it solves it. Okay, if I were to graph it, what happens at negative 2, negative 3? That's where the two lines cross each other. And so I did that without actually graphing it, right? So I found that place where there's two graph, right? So like wherever that would be, this is at 2, negative 3. Wherever they cross, right? That's what he looks like. Okay, now sometimes you end up with funny business happening. Okay, let me show you what those look like. So here is this example, and they let us decide, would you rather do substitution or would you rather do elimination? Would you rather substitute or eliminate? What?
Substitution.
You would rather do substitution? You think substitution's easier? I like to eliminate. I'm an elimination person.
I don't think elimination would work.
Yeah, elimination will always work. Kinda.
Cancels all the variables.
Oh boy. Let's do elimination. So which one would you like to eliminate, X or Y? You're thinking too hard. Would you like to eliminate X or Y? Just answer. Y. Okay, so let's eliminate the Y's. So one of them is a 3 and one of them is a 9, and they have to be the same number. So we have to multiply the top by 3, but not just 3. We have to multiply him by negative 3, because in order for him to be a negative. All right, so here's the deal. We multiply 3 by negative 3. Okay. Negative 3 times 5 is negative 15x. Okay. Negative 3 times 3 is negative 9y. Oh boy, that's going to be like negative 156, I think. Yeah? Yeah? Okay. Now I'm going to write the other one right below it. So 15x plus 9y. We were trying to eliminate the y's, right? We were trying to eliminate the y's. Okay? And so the y's cancel out, negative 9 and positive 9. But the problem is the x's also cancel out, right? So I have my equal sign here. What's left on this side? Nothing. So we put 0 equals, and then if I put these two together, negative 156 and positive 54, that's negative 102. So I end up with an equation that says 0 equals negative 102, and I don't even have an x or a y, okay? So then I ask myself, like, okay, when does 0 equal negative 102? Never, right? This never happens, which means that we have no solutions, right? There's no solutions to this. No solutions. Do you know what these look like when they are graphed if there are no solutions? They're parallel to each other, right? Parallel means no solutions, because parallel, they don't touch, right? So these two lines would end up being lines that are parallel. Does that make sense? So like when you're doing substitution elimination and you get a funny answer, it's usually because something like this is happening. No solutions, okay? So let's go to this other one because something else funny is going to happen. Would you like to do substitution or elimination here?
Substitution.
You want to do substitution?
Or do we?
I don't care. It doesn't matter. We did elimination on the last one. Should we do substitution on this one? Yeah? Okay, let's do substitution on this one. So, which variable would you like to solve for? You're wanting to do elimination. Yeah.
The first y.
The first y. You want to solve for the first y? I want to solve for the first x because I like dividing by 2. I think it's easier dividing by 2. Can we divide by 2? Let's solve for x. Okay, right there. Let's solve for x. So, if we're going to solve for that x, let's kick the y to the other side. So I minus the 3y and minus 3y. Okay? All right, that will be 2x equals, and we have negative 3y plus 15. Yeah? Okay, then what? Divide by 2, divide by 2, divide by 2. Okay, so x equals, what's negative 3 divided by 2? Mm-hmm. Now, normally we leave it as negative 3 over 2, but since we're going to plug in, I'm going to put it as a decimal. So negative 1.5y plus, what's 15 divided by 2? 7.5. Okay, so x is equal to this. Put a box around it if you need to. X is equal to that. So now what I do is I take that whole big chunk and I plug it in for x. So this x is now going to be replaced with that big chunk. Okay, so I have negative 4x, and x is now that big chunk, negative 1.5y plus 7.5. Okay, then what else? I still have minus 6y equals negative 30, yeah. Okay. All right, and then what?
You just distribute the 4.
Yes, exactly. Distribute the 4. Okay, so what's negative 4 times negative 1.5?
6y.
Yeah, positive 6y. Okay, and then what's negative 4 times a positive 7.5? Should be like negative 30. Okay, minus 6y equals negative 30. Okay, we got more funny things that are going to happen here. Okay, so let's do some stuff. What would you like to do?
Combine the 6.
Okay, what about 6y minus 6y?
You can combine them.
Yeah, it ends up canceling each other out, right? 6y minus 6y, they're gone, right? So what we have now, basically, I mean, you could add the 30 over to the other side if you want to, but we basically now have negative 30 equals negative 30, and all my variables are gone. When does negative 30 equal negative 30? All the time, always, right? Okay, this is always true, which means that we have infinitely many solutions. And do you remember what that looks like when you graph it?
One giant line.
Yeah, it's just one giant line, like the two lines are on top of each other, right? Yeah, infinitely many solutions. So when you get to a point where like all your variables are gone and you have like a number equals itself, that's always true. It's infinitely many solutions. Versus over here, if you get like 0 equals negative 102, which doesn't make sense. They're two different numbers. No solutions, never going to happen, right? Parallel lines, okay? So like, yeah, when we're not graphing, you can see like what it looks like for substitution elimination for those things to come out. Not nice, okay? Good? Makes sense? Okay, so Olivia, I told them already to, on the skills practice side, to go ahead and do like 4, 6, 7, and 8. They don't tell you which method to use. I don't care which method you use. If you think elimination is easier for one of the cases, you go ahead and do elimination, okay? Or if they say substitution, or they don't tell you which one to use. So if you think whichever method you think is easier, do that one, okay? So 4, 6, 7, 8 on that page, and then on the back side, on practice side, do 4 and 5. Okay, you should already have 1, 2, and 3 done on each side. 4 and 5. So I won't even make you do a story problem. Okay, that is all that I have for those guys. Okay, that's it. Any questions before I end the video? Okay, bye, Olivia.